Remember a few years back when you heard about the discovery of water on Mars? Nilton Renno, a professor at the University of Michigan's Department of Atmospheric, Oceanic, and Space Sciences, is the guy who encouraged NASA to point a camera toward the planet. If there was water near the surface, the rocket plume would melt it and it might splash onto the landing gear. Sure enough, the globules acted like water. Turns out Professor Renno is fascinated by something else the Earth has in common with Mars.
How did you get interested in studying dust?
My hobby is to fly gliders, so flying over the desert and seeing dust being lifted everywhere, and especially the little tornado-like vortex, dust devils.
As I understand it, you started to discover, especially on Mars, that the prevailing theories about how dust works were wrong.
Yeah, the puzzle was what's the wind speed that you need to lift dust? And according to this theory, you would need wind speed of 80 meters per second.
Why so fast? Because being on the surface there is like being at 100,000 feet here. And with air that thin, it would have to be traveling at least 180 miles per hour to create the massive dust devils that Pathfinder was observing. But if wind didn't explain the dust devils, what did? NASA wanted to know the answer from Mars, so they funded some field testing closer to home.
One of the things that we were measuring is the electric field. And our first measurement, a dust devil came through, and we saw an electric field of more than 10,000 volts per meter. So then I said, wow, my God, that maybe this has an effect in the dust lifting.
Those initial measurements were suspect because a sensor that could accurately measure those electromagnetic fields didn't exist. So Professor Renno and his team invented one. Stephen Rogacki is a senior engineer in research at the University of Michigan's Space Physics Research Lab, or SPIRL.
We needed something that we could measure electric fields very close to the ground, for one thing. So we needed to be a small geometry, a narrow geometry. And we also wanted something that was very sensitive. It had a very wide dynamic range.
The new sensor is more than just fun at parties. The accurate measurements it's provided have helped substantiate Professor Renno's theories about how dust devils form.
The small particles get loose, they can be ejected from the surface by the electric forces.
Harvey Elliott endured what was lovingly referred to as being sandblasted for science.
With the dust devils, we'd pretty much find a place where we knew there were going to be hundreds of them in a day, and hopefully one would hit.
And then what happened when they hit? What was that like?
It was a whole lot of dust. You didn't want to open your eyes for sure, and I've probably destroyed about 2 cameras out there.
Renno's electrostatic sensor had now been field tested in excruciating conditions and worked. And as he presented his findings at scientific conferences around the world, electronic industry representatives told him his new sensor had commercial applications as well. But to explore those opportunities, he needed help.
So is there anything in particular about Michigan or the University of Michigan that makes this possible? Are there special resources that you got here?
Yes, I think it's the venture acceleration and the business engagement center and all the mentorship that we got from them. They really know what it takes to make a successful business. It's not just the technology, it's much more than that. The technology is just one of the many ingredients that you need.
Dave Hartmann is a mentor in residence at the University of Michigan's Office of Technology Transfer. He explained to me the need for measuring electrostatic discharges in industry.
You might touch a doorknob and get a big spark. That probably was 10,000 volts. It didn't have a lot of current, but it zaps. And when that kind of a spark hits electronics or small molecule drug development or is in a grain silo or an ammunition dump, you have lots of problems. There are $10 billion worth of damage to electronics every year due to those sparks.
And the Electrostatic Association predict that the bottleneck for miniaturization might be this electrostatic discharge.
So a crucial application from dust devils may end up being that it makes it easier to make smaller electronic components.
And more reliable electronic components.
So from curiosity about tiny specks of dust in big storms on Mars, the transferable technology is in development here on Earth. Just one more reason we reach for the stars.